Hi, my name is Tiffany, and this is Lab 1, Constant Velocity. So, introduction. The purpose of this lab is to observe an object in motion moving at constant speed without altering its direction, and then analyze and extract that object's positions and corresponding times, and then compare it to the computational model that was created. The fundamental physics principles used is Newton's second law, which states that the net external force equals the change in momentum of a system divided by the time over which it changes, which can be seen in this picture right here with the formulas. And then Newton's first law, which states an object at rest or in motion will continue its path or continue what it's doing unless it was acted upon by an external force. And so preview, though the observed model and computational model is very similar, they will show the impact of external forces causing the discrepancy between the data that was collected. And assumptions, we assume that there was no friction or resistance in this lab for our purposes. Next. So the other physics ideas used, constant velocity means an object that was moving at constant speed and direction and its velocity didn't change. And the formula used is x equals x naught plus vt. Net force is the total force acting on an object and the vector sum of all the individual forces added together. So F equals ma, m is mass, a is acceleration. The velocity update formula is shown right here, which I'll demonstrate how to use later on. The position update formula, as you can see in this picture here, describes how an object's position changes over time. Rf is the final position, Ri is the initial position, v is average velocity, and delta t is duration of time. So procedures. I recorded a video of a lip balm rolling across the screen at constant speed and in the same direction, then imported the video into Tracker and tracked the lip balm's position by frame, then created a model of the lip balm's predicted position in GlowScript by inputting the data that was collected into the code and generated an Excel sheet with the observed and predicted position data, and then had Excel generate a graph comparing the data in conclusion. So this is what it looked like in Tracker. Okay. Next, tracker analysis. So the total time that it took was 1.633 seconds, and the initial position that was tracked was negative 0.01153, and so I took the final position 1.221 subtracted by the initial position, and then divided by the duration of time it took, and got 0.755 as the initial velocity. So with the computational model, I set net force equal to 0, inputted the initial position and initial velocity here, and I set delta t equal to 1 over 30 because that's the duration of each time step. The mass of the lip balm isn't taken into account here, so it wouldn't affect velocity. And the position update formula is used to predict the position, as you can see, it's written here. And so this is the graph that was generated, and the dotted line is the observed position and the straight line is predicted position. So what we see from here is that as time goes on, the observed position eventually diverges from the predicted position, which indicates that there was an external force that slowed down the object and eventually stopped it, and this could be friction or air resistance. And so this is what it looked like in Tracker. So what are the possible errors? Position tracking could have an error in it by from placing the center of mass in Tracker due to human error, because I'm not perfect. And then there was a rounding error that could be possible because rounding isn't precise every time, and therefore it could add some deviation to what we see from the predicted position. And the outside forces, so though we're not taking into account of these outside forces here, these forces do exist, and this is what we see from that was affecting the system. And the system was the lip balm, the surroundings is everything that was around it. And so what if negative x and positive x were switched? So the slope of the graph would be negative instead of positive So everything was just swapped. We're just changing the signs. And what does it mean net force is zero? So the computational model overestimates the position of the lip balm at greater time intervals, but there were other resistive forces acting on it and didn't give the entire system a net force equal to zero. Like horizontally, but vertically, there was net force of zero because the lip balm didn't move vertically, and so gravity was at play. Yeah, so that was it. And thank you for listening to my lab.